Hey guys, I'm going to go through the last new thing actually you're going to learn this year. We've already done the quadratic formula. So you had some practice with that on Friday where you plugged in A, B, and C into this formula. If you haven't listened to the song yet, you should. It'll help you remember it. I posted it on Google Classroom. But anyway, here's the new part. Okay, so in the square root, or under the square root of your quadratic formula, you have the expression b squared minus 4ac. Okay, that is called the discriminant, and that gives us information about how many solutions, real number solutions, we're going to have when we solve for x. Okay, so you probably figured it out a little on your own when you did the other homework assignment, but if you have a 0 that you get under the square root for the discriminant, you will only get one real solution. So the graph, if you were to graph it, the parabola, it would have one x-intercept, okay? One x value, that's the solution. Okay, if it's greater than 0 under the square root sign, you'll have two real solutions or two x-intercepts. And if you remember from before, the reason there were two solutions was because of this plus minus that you had to work out separately. So that's the second situation. And the third situation, when you had a negative under the square root sign, less than 0, you would not be able to get a negative square root. At least in this class this year, you are not able to do that. We're going to say no real solutions when that happens. There is no x-intercept when that happens. So for our purposes, we don't go further when we have a negative under the square root, but in high school you will. And there are actually imaginary numbers that you can use when you have negatives under the square root, okay? But I just want to talk through what I did in this first example here. Sorry about the hole punch there, but A is supposed to be 1, B is -4, C is -7. So this is a general solve using the quadratic formula problem. Okay, so I'm just doing what I did on Friday, but I want to show you that sometimes you get decimals and it's perfectly fine. Okay, so I'm not going to work through the whole thing, but you'll see as you go through the square root step or whatever's under the square root, you get 44 in my work. 44 does not have a perfect square root. So when you type it in on your calculator, round the answer that it gives you to the tenths. And I did that here. So it's okay to have a decimal. But remember, this is a positive 6.6. So we need to do the plus and the minus step separately. So for this example in the notes, you get one answer, which is approximately 5.3, and another one, which is approximately -1.3. So you will round within the problem and use that number to do your plus and your minus. Okay, so just expect to see decimals now. I just want to make sure you guys know it's perfectly fine. Okay, all right, now I'm going to do the next three with you and show you each situation. This is the new material where we're using the discriminant to tell how many real solutions the quadratic equation will have. It's also telling us how many x-intercepts the parabola will have, which it's shown at the top of the notes with the diagrams. Okay, so just remember, the discriminant is b squared minus 4ac. It's just a small part of the quadratic formula. Okay, so for number 2, I'll go ahead and do that one. It's written correctly where it's set equal to 0, so that's good. You're going to do A is -1, B is +4, C is -4. So you still need to find A, B, and C, but it's not going to take you as long because you're only doing b squared minus 4ac. So that would be 4 squared minus 4 times -1 times -4. And that would be 16 minus 16, which is 0. And if you go back up to the top, getting a 0 for this discriminant value means there will only be one real solution. Okay, so that's all they're asking us is to find out how many solutions there are. And it also means there is one x-intercept. Okay, if they were asking us to actually give the solutions, we would use the quadratic formula for that, but we're not asked to do that. All right, this one right here, it's not quite written in set equal to 0. So move that over. So then the formula would be, or the equation would be 6x squared plus 2x plus 1 equals 0. So what I did is I added 1 to both sides. Okay, so A is 6, B is 2, C is 1. So you're going to do the same thing as before. You're just going to plug it into the b squared minus 4ac. So that's 2 squared minus 4 times 6 times 1. And that would be 4 minus 24, which is negative 20. That's a negative answer. So that means that we will have no real solutions. And that also means at the same time that there are no x-intercepts if we were to graph that. So that just means the vertex is not going to be on the x-axis. Okay, so the last one is still, again, not set equal to 0. So make sure you do that. If you subtract this and add this, here's your new equation. 1/2 x squared minus 7x plus 1 equals 0. So that's rewritten the way that you want it. Now just set your A is 1/2, B is negative 7, C is positive 1. So get that all together and then just plug it back in like you've been doing. So that would be negative 7 squared minus 4 times 1/2 times 1. Okay, so that's 49 minus, this is 4 times 1/2 is just 2. So that's 47. That's a positive answer. So that means you will have 2 real solutions. And you'll also have 2 x-intercepts. And that's all they asked us to do, was to tell how many solutions the equation would have if you were going to solve it. Okay, so hopefully that's making enough sense where you can get through the assignment. You're going to be doing in the assignment a mix, okay? So you're going to be using this for some of the problems to get the actual solutions, which will probably be decimals. And then you'll use the discriminant to tell how many solutions there actually are. Okay, so let me know if you have any questions. Thank you.